Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture. So we were discussing chapter number 5 of the old syllabus, input and output devices, and if you're following the new syllabus, then section 3.2. In the previous lecture we have already discussed input devices and monitor and control systems. Now we are going to start output devices. As discussed before, output devices are those devices which are used to get an input or a result from computer. So the first output device which we have is actuator. An actuator is a mechanical component, typically a motor, a relay, or a solenoid. In Cambridge syllabus, it is mostly considered to be a solenoid that carries out an action when a computer gives it an instruction or a signal. For example, a digital camera has an actuator built into the lens, and the motor moves the lens in and out depending on the level of zoom required. It is the actuator that controls this movement. Actuators can be small, as in the case of a camera, or they can be very big, such as those actuators which control heavy duty computer controlled drills, or hydraulic jacks which open and close automatic doors, main gates of large houses. They can be used to turn a device on or off through a signal from the computer, for example a heater, a fan, a motor, an alarm, a searchlight, etc. Next we have printers, and in our syllabus in the Cambridge we have three types of printers: inkjet, laserjet, and 3D printers. So let's have a look at them one by one. Inkjet printers use liquid ink cartridges, and they contain printheads which consist of hundreds and thousands of tiny nozzles which spray droplets of ink onto the paper to form a character or an image, depending on whatever you're trying to print. Inkjet printer uses two technologies. Some of the manufacturers, they make printers which have thermal bubble technology, and some of the manufacturers have piezoelectric or piezoelectric technology. You should know the difference between the two. Thermal bubble technology In thermal bubble technology, there are tiny resistors or heaters behind every ink nozzle, and they are used to create heat which makes the ink vaporize and form ink bubbles. When bubbles expand, ink is pushed out of the nozzle and ejected onto the paper, whereas when bubbles collapse, vacuum is created to suck up fresh ink to be drawn into the printhead. And piezoelectric, behind each nozzle of the ink reservoir, a tiny crystal is placed. When the crystal is given a small electric charge, it vibrates and causes the ink to be ejected onto the paper, as well as more ink is drawn into the printhead for more printing. Next we have laser printers. In laser printers we do not have liquid ink, rather we have dry powdered ink which is called toner. Unlike inkjet printers, they print much higher quality documents. They print the whole page in one go and at much faster speed. At the start of printing, a print drum is given a positive charge, and when the drum rotates, a laser beam is scanned across the drum, creating a negatively charged area onto the drum in the shape of the document or image that is to be printed. The drum is then rolled on to the toner, which is positively charged, hence it sticks to the negatively charged areas on the drum. A negatively charged paper is then fed, and the toner sticks onto the paper to produce a copy of page sent to the printer. After one rotation of the drum, charge on paper is removed so it may not stick to the drum. The paper is then passed through a fusor. It is basically a heater which melts the ink particles and sticks them onto the paper permanently. Lastly, the charge on the drum is erased to make it ready for the next print. Now, what is the inkjet versus laser? You should know these two applications. If you have to print a few photos or pages in high quality, then you should go for inkjet, because colors are much better in inkjet. And if you have to print something in bulk quantity, then you should go for laser printers, as they can making 500, 800, 1000, 1500, 2000 copies is not an issue for laser printer. So if you want a fewer pictures, you should go for inkjet. If you want bulk quantity of something to be printed, either brochures, flyers, pamphlets, whatever, then you should go for laser printer. Next up, we have 3D printers. 3D printers can print 3D objects or models which actually work, such as small toys or gadgets or prototypes, etc. They use additive manufacturing, means that object is built up by layer by layer. 3D printers can use plastic, powdered metal, paper, or powdered ceramics. There is two type of 3D printers available. One follows the direct 3D printing method, the other follows the binder 3D printing method. In direct 3D printing, it is same as the inkjet technology. The print head can move both horizontally and vertically. There are basically two print heads, and they move along the X, Y, and Z axis in order to print something layer by layer. Basically, what happens in direct 3D printing is that whatever you are using as input, either it be plastic or powdered metal, then it is melted and then it is sprayed through the nozzles layer by layer. Since it is melted, then while it cools, the different layers stick with each other and ultimately an object is formed. Whereas in binder 3D printing, it uses two passes or two phases to print. First of all, one layer of powdered metal or powdered plastic is sprayed, or whatever, or powdered ceramic is sprayed, and then on top of it a binding agent or a glue is sprayed so that the layer solidifies, and on top of that a second layer is sprinkled, and then comes the glue, and then another layer of powdered raw material, and then the binding agent, and so on until the whole model has finished. Next output device we have are 2D and 3D cutters. These cutters are controlled by computer and complex designs can be crafted using them. They can cut through materials such as glass, polymer, wood, crystal, metal, stone, etc. 2D cutters can cut 2D designs, for example, cutting gears, different gears out of or different patterns out of metallic sheet. And 3D cutters can cut 3D designs, for example, feeding in a block of marble, and the 3D cutter would craft an ashtray or art piece or a showpiece or a vase out of it, a flower vase. Next we have speakers, loudspeakers, headphones, or whatever type of speakers you can think of. These are the devices that output sound. This is done by converting digital data into sound signals by use of a DAC, digital to analog converter. Sound is produced by voltage differences vibrating a cone in the speaker, housing at different frequencies and amplitudes. Basically, speakers are the exact opposite of a microphone. In microphone, what happens when you speak, the vibrations cause a cone or a diaphragm to move, which is attached to a coil that is wrapped around a magnet. When the coil moves in a magnetic field, then an electric charge is produced. In the speakers, the opposite happens. The computer provides the digital data which goes into a DAC, digital to analog converter, which converts that digital data into electrical signals. Those electrical signals are given to the coil wrapped around a magnet. When the electrical current is provided to the cone, it vibrates because there is a magnetic field around it, and when it vibrates, along with it the attached cone of the speaker also vibrates, producing sound. Now there's a term which you should know about speakers, that is sampling rate. The speed at which DAC can convert digital signals into analog voltage is known as sampling rate. Next output device we have are monitors, specifically LCD and LED monitors. LCD are the liquid crystal display monitors. In LCD monitors, front layer of monitor is made up of liquid crystal diodes, which are grouped together in a pair of 3 each. Together these 3 diodes represent the primary red, green, blue colors and form 1 pixel. Some systems include a 4th yellow diode in each pixel as well, in order to make the output image more vivid, more colorful, have better color combination. A CCFL, cold cathode fluorescent lamp, is used to backlight the LCDs. Backlight technology is necessary in an LCD as LCD can't produce its own light. Now the updated version of LCDs are LED monitors, light emitting diode monitors. LCDs are backlit. Modern LCD monitors are backlit by a matrix of tiny LEDs, hence the name LED monitors. What are the advantages of LEDs? They reach maximum brightness as soon as turned on, while LCDs need light warm up or a slight warm up, because CCFL lamps need a few seconds to reach full intensity. LEDs give a whiter light which sharpens image and makes the color more vivid. LEDs have improved color definition. LED monitors are much thinner. They have longer lifespan. They use very little power, hence lower power is consumed and less heat is emitted. Nowadays the technology has developed further, and we are able to develop a new technology that is known as OLED, or organic light emitting diode. It uses organic materials to develop a very flexible layer of semiconductors. This thin organic film is placed between 2 charged electrodes, metallic cathode and glass anode, and when electric charge is applied, the electrodes give off light. Hence, no backlit technology is required, making the monitor even thinner than ever. OLEDs also allow the screen to be curved due to its flexibility. Advantages: they are thinner, lighter and more flexible. They can be made from plastic rather than glass. They give a brighter light than LED. They do not require backlit technology. They produce their own light and consume very less power. Based on plastic, they can be made into very large thin sheets to be used on advertising panels on the sides of skyscrapers. They have a very large field of view, about 170 degrees, means you can curve them at around 170 degrees angle. The only drawback of OLED is that it is a new technology, so it is quite costly. Next output device we have are light projectors. These output devices project computer output onto a large screen or on an interactive whiteboard. They are commonly used for giving presentations or to project a movie onto big screens. There are 2 types of light projectors: digital light projectors and LCD light projectors. Digital light projectors or DLPs, they use millions of micrometers which are aligned on a small DLP chip, and a bright light source, usually a xenon lamp, is used to produce light which passes through a color filter and splits into 3 primary colors. The split light then falls onto the DLP chip. Different color combinations are achieved by on and off state of each of the micromirrors. See, this is a light source or a lamp. It magnifies the light through a lens which falls onto a color wheel or a color filter which breaks the light into its three components: red, green, blue, and sometimes violet. Then it falls onto a DLP chip. DLP chip is something like this. It has millions of micro mirrors on it, and the angle at which a mirror is placed marks it as on or off. And by turning on and off, different combinations of mirrors can produce different shades of a color. And then so this procedure basically makes a red, a green, and a blue image of the original screen, which goes through a lens and is projected onto a screen. And now the change between colors happens so quickly that on the screen, instead of seeing different colors, we actually see a colorful image of your computer screen or whatever you're presenting, instead of seeing a green, red, or blue version of the actual image. The next up we have LCD projectors. They are older than DLP technology, and in an LCD projector, a beam of white light passes through an LCD display and falls onto the screen. The beam of light is sent to a group of chromatic coated mirrors which split into three primary colors. The split light then passes through three LCD screens which show the image to be projected as a grid of millions of pixels. When light passes these three screens, RGB versions of the images are obtained. These images are then combined using a special prism to produce a full color image. Lastly, the image passes through a lens and falls onto the screen. This is usually how a LCD projector works. We have a light source, usually a xenon lamp, and it passes through chrome coated mirrors or dichroic mirrors, and when it passes through these mirrors, the light breaks into red, green, and blue, three different colors. And then there are tiny LCD screens, three screens, which mimic the image that is to be shown. And when light passes through these three LCD screens or these three LCD filters, then three different versions of one of red, one of green, one of blue of the actual image to be projected is obtained. Once that is done, then over here is a special prism. These three images go into the prism, which combine the three images into one colorful image. That image is then passed through a lens, and through the lens it falls onto the screen. Thank you. Take care. I hope you have understood everything. Feel free to ask me if you have any problem. Take care. Allah Hafiz.